Yeah, good morning, everyone. Can you hear me?
Yes, good morning. Can you hear me, please?
Yeah, I can hear you. I can hear you. Mr. Sherman, I'll place it on now.
Hi, good morning, everyone. Hey, testimony, good morning. I think we can give some 5-10 minutes to allow some people join before we start. Maybe we'll start at 10:10.
All right, no problem. I'll be on standby. Good morning, everyone. If you are just joining, we are waiting for other people to join and we'll start the meeting at 10:10. Okay, everyone. Good morning. It's 10 minutes after 10, and we'll be starting now. So I welcome you to this session. Please, if you can hear me, react so I'll know if everyone on this call can hear me. All right, thank you very much. I'll be sharing my screen now. So I welcome you to this technical session organized by NAPI Young Professionals. Thank you for taking out time to join us. Today's topic will be Beyond the Seismic, Data-Driven Geoscience for the Future of Energy. And we have a speaker, experienced professional. His name is Perkins Offie, and my name is Testimony Adamu, and I'll be your moderator for this session. This is our agenda. We'll start with the opening remark taken by the head of the technical committee, Dumame. We'll then have a safety brief and introduction of the facilitators. Then webinar presentation, which will run for 45 minutes. After the webinar presentation, there'll be quiz session. So try to pay attention so you can win something. There'll be prizes to be won. Then after the quiz, we'll have the question and answer session, which will run for 20 minutes. So during the course of the presentation, you can write down your questions. Then when it's time, you put it in the chat box or you can come off mute. Then we'll have the vote of thanks taken by the YP team lead, Oluwaseun Ogundipe. Then announcements taken by the publicity secretary, Abioye Banjoko, and we'll have our closing remark and we'll be done. So for the opening remark, I call on Dumame to please take the opening remarks for 5 minutes.
All right. Please confirm you can hear me, Testimony.
Yes, I can hear you, Dumame.
All right. Okay. So my background may be a little bit noisy because I'm on transit on my way to the airport actually. So just bear with me, please. Good morning, everyone. You're welcome to the technical meeting for month. And we, as a technical committee, we know this topic is very key at this point in time in the 21st century. In fact, I think a couple of weeks ago, I had a section with some students in Unizik. I think for their Geoscience week, I joined them virtually, and then their theme was Geoscience in the 21st century, the digital revolution. And we talked about the impact of technological advancements in the role of geoscience in the 21st century. We talked about a lot of things, talked about AI, machine learning, and all of that. So at this point in time, it's very critical that we look beyond seismic because geoscience has evolved from just only seismic and well data to a lot of other data, and it's very key that we key into the data-driven aspects, right? Because we have to integrate a lot of data together. I mean, the modern scientists, we have to integrate a lot of data together. So the facilitator for today is a very seasoned person, and we believe is going to do just to topic. So I would advise you all to sit down for pen and paper, and not as much as you can. Then you have questions after this event. So you're all welcome. And we also have some new guys from NMPC, our new graduate trainees that are going to be joining the meeting. So I'm wishing us thank you very much. Over to you, Testimony.
Okay, thank you very much for that opening remark. So very quickly, I'll be going into the safety brief. First thing I would like to draw attention to is that this webinar will be recorded. So please avoid sharing any personal or sensitive information in the chat. We will not be responsible for any information that you leak through this meeting. Microphone and noise control. All participants should be muted upon entry. Kindly remain muted unless you are called upon to speak. This is to reduce background noise. During the question and answer session, you have the opportunity to speak, and that's the only time you should unmute your mic. Chat etiquette. Use the chat function respectfully and for relevant questions or comments only. Any form of offensive language will not be tolerated during the session and you'll be removed from the call. Technical safety. Please do not click on suspicious links shared in this chat. Only follow links shared by the host or the designated speakers. So any link that you see shared in the chat, if you don't see it shared by the speaker, the publicity secretary, or myself, the moderator, please do not click on it. Environment awareness. Be aware of your surroundings. Choose a quiet place for full concentration. Let others around you know you are in a meeting. If you are joining with a headphone, keep your headphone volume at a moderate level to protect your hearing. So I'll be introducing our speaker now. And this is a brief profile of our speaker. Perkins hails from Delta State, Nigeria, and is a data geoscientist with a strong academic background and professional background. He graduated with a first-class honors in geology from the Federal University of Petroleum Resources, Ephraim, Nigeria, where he also served as the president of the NAPIT student chapter, demonstrating early leadership and commitment to advancing the field. Following his undergraduate studies, Perkins was awarded 2 prestigious international scholarships from SPDC and AGIP, which enabled him to further his education abroad. He earned a master's degree in integrated petroleum geoscience from the University of Aberdeen, Scotland. Recognizing the evolving landscape of the energy and technology sector, and driven by both curiosity and foresight, he went on to pursue a second master's degree in data science at the Robert Gordon University, also in Scotland. Upon completing his studies, Perkins began his professional career as a data geoscientist at Earth's data giant, Viridian, where he works at the intersection of geoscience and technology. In this role, he collaborates with a multidisciplinary team of scientists, engineers, and developers to deliver innovative, data-driven solutions to real-world challenges across multiple industries. Beyond his professional achievements, Perkins is deeply passionate about inspiring and empowering the next generation. He actively volunteers with the Association for Black and Minority Ethnic Engineers, AFBE, where he assists individuals from underrepresented backgrounds, helping them break barriers and confidently pursue careers in STEM. Outside of work, Perkins enjoys traveling, photography, and football, passions that allow him to explore new cultures, capture meaningful moments, and stay connected through sports. Please, if your hands are not too busy, use the react button to welcome our speaker, Perkins Offie. Perkins Offie, you have the floor now.
Thank you very much, Testimony. Really appreciate that introduction. It's sometimes a bit weird listening to someone talk about you. But yeah, thank you so much. Thank you everyone for joining. It's an honor to be here among colleagues. It's been a while. I would say this is like coming back home. So I remember back in my undergrad, I was deeply involved in NAPI activities, and now it's full circle, and I'm really happy to be here. So I would like to invite people to please pay attention, learn as much as you can, and take away what you can from today's session. So I'm just going to share my screen and get on with the presentation. So please let me know if you can see my screen.
Yes, I can see your screen.
Okay, and is it in presentation mode?
Yes, it is.
Okay, super. Thank you. Right. Okay, so yeah, I'll go straight into it. Well, as you know, my name is Perkins Offie. I'm a data geoscientist, and today we'll be exploring an exciting theme beyond the seismic, data-driven geoscience for the future of energy. Now, today's presentation is not so much a technical session as it is a call to action. So this is a call to everyone in this meeting at the moment to act and do something about what I'll be talking about. Right. Seismic. I know a lot of geoscientists are on the call, and when they see something like this, the first thing they want to do is quickly start looking for horizons, looking for faults, and trying to interpret and all that. But that is not what we're doing today. As much as we all love to do it, that is not where we're going today. We're going beyond that a bit. So for the past decades, Seismic has been the cornerstone of subsurface imaging, as we all know. Is the tool that defined modern petroleum exploration, being able to visualize the subsurface, see what's going on down there. But the future demands more. We need more accuracy, we need more integration, we need more speed. And in that quest, geoscience is increasingly intersecting with data science, artificial intelligence, and machine learning. So the question before us today is, how do we as geoscientists evolve in this new landscape? How do we leverage data-driven tools to remain not only relevant, but central in the future of energy? Right. So let's begin with a simple question. Why must we think beyond the seismic? Seismic is powerful. We all know that. Allows us to see beneath the Earth's surface in 3 dimensions, but it has its limits, right? Firstly, we have reservoirs that are becoming more and more complex. If you're thinking of, say, reservoirs like fractured carbonates, you're thinking of deep-water turbidites in the Niger Delta. Imaging alone cannot fully reveal the heterogeneity or the fluid behavior within these reservoirs. And then there's also the place of the energy transition, where we have an expansion in our mission as geoscientists. So it's no longer just finding oil and gas. Now we are tasked with evaluating CO2 storage reservoirs, identifying geothermal prospects, and assessing hydrogen storage sites. And then also, there is also the problem of decision making. Back in the day, you could take a long time to study the seismic, interpret it, go back and forth. But now the time has reduced, so the pace of decision making has accelerated. What used to take months must now take weeks or even days. And investors and regulators, they want faster and data-backed answers. They don't just want you to say, oh, I think this is what it might be. I think this is what it should be. They want you to give them answers and say, okay, based on this data that I have analyzed, this is what it is. They need that certainty. And this is where data-driven methods come in. Machine learning and AI can help to process data sets far larger and more complex than any human brain could handle at the moment. So they allow us to see subtle patterns beyond human eyes. So the things that you might miss, a good machine learning algorithm, artificial intelligence, will be able to spot them. So the point of this presentation is not to abandon the seismic, is to enrich it, to push past the traditional boundaries. Now we're in the middle of a data revolution in geoscience. Think of all the sources of data we now have at our fingertips. We have seismic 2D, 3D, and now we even have 4D time-lapse surveys. We have different types of well logs from gamma ray, resistivity, density, and all. You have core data, you have drilling and production data, and even satellite and geospatial data. Now, the result of this is a flood of information. So not just gigabytes of data, but we're talking terabytes and petabytes, large amounts of data. And if you're familiar with the data terminologies, once it begins to get into that amount, then we're talking big data. That's where the term big data is coined from. And for those who are also familiar, you know big data has the 5 Vs, the 5 V attributes. out of which I've taken just 3 to discuss this point I'm trying to make: the volume, the variety, and the velocity, right? Now, the volume, we have massive seismic surveys or national data repositories. For anyone who has worked with seismic data, you know how large one seismic survey can be, the amount of memory it consumes. For variety, we have structured data like last logs. We have unstructured data, PDFs, core photos, images, all sorts of unstructured data. And for velocity, we now have access to real-time drilling feeds and streaming production data at the point of drilling or production. Now, the challenge is, how do we integrate all of this? Historically, we've had geoscientists work in silos. The seismic interpreters have their own cube, they're working in one space. The petrophysicists have their logs, they're interpreting logs in another space. Then we have reservoir engineers building their reservoir models in another space, everybody working in different silos. But today, data lakes, cloud computing, and AI platforms give us the chance to break down those silos and to look at the subsurface holistically from the same point at the same time. Now, I know when I mention cloud computing, a lot of people can be skeptical, especially companies in Nigeria, for instance. They're still very skeptical about having their data in the cloud due to maybe data security breach issues. They're worried, oh, if I put my data in the cloud, what's going to happen to it and all that. And it's our responsibility as young professionals to bring that change and let them know that these new advancements in technology is for our benefit, and we have to look beyond, if anything, prefer solutions for what we're afraid of so that we can move forward. So this brings me to the intersection of geoscience and data science. Now, each domain has its strengths, right? The geoscientists, most of us are here in the call, geologists, geophysicists. We bring context. We understand the positional systems. We understand tectonic history. We understand rock physics. We know what a seismic amplitude can represent, why one seismic amplitude will represent sand in a context and another would represent shale. We know all that stuff. Then the data scientists, they bring the tools. They bring machine learning algorithms. They bring deep learning architectures. They bring statistical models and the ability to handle huge data sets. Now, when these two domains collide, the result is usually transformative, right? This is where innovation comes in. When geoscience and data science meet, it breeds innovation. So, for example, a geoscientist may spend months manually picking faults, while a convolutional neural network, a CNN, can learn the patterns and propose interpretations in hours. And as the day goes by, even less. You can get interpretations in minutes, even depending on how well the model has been trained. But if the network is not trained with geological context, it might make mistake, and it will mistake maybe noise for faults, right? So this is where that context that the geoscientist brings is still very relevant. Because if you remember back, say maybe you were in primary school and whatnot, where you're told garbage in, garbage out in computer science. So it's whatever you give the computer that it's going to give back to you. So if you train it wrongly, it's going to give you wrong answers. And therefore, it's important that a geoscientist knows what should be correct and should be able to spot these things. So that's why collaboration is key. And the best outcome is when geoscientists guide the questions and the data scientists provide the computational power. Now we'll look at key applications of these technologies I'm talking about beyond just manual or traditional seismic interpretation. So we have seismic interpretation automation. We have deep learning, particularly CNNs, like I said earlier, which can automatically detect faults and horizons. You have attribute-based machine learning classification that can map depositional facies and reduce interpreter bias. In the field of well logs as well. We have supervised machine learning regression models that can predict porosity or permeability from incomplete log suits. We can use clustering algorithm for lithofascist classification, even when the core calibration is limited. We can carry out outlier detection, which can detect suspicious log runs for quality control. There's also drilling optimization. Real-time analytics can detect early signs of stock pipe, wellbore instability, or kicks, all of these which are very essential. And reinforcement learning can suggest optimal drilling parameters, saving millions in non-productive time. For those who have worked in the rig, you know how much it costs really for just 1 day of drilling. It's a whole lot of money. And then there's also production forecasting and anomaly detection. Machine learning decline curve models normally outperform your traditional exponential or hyperbolic methods. You have anomaly detection that can flag early equipment failures or unusual reservoir responses. And finally, there is the energy transition, where in carbon capture and underground storage, machine learning can help us to evaluate seal integrity and simulate CO2 plume migration. In geothermal, we can use machine learning to identify heat anomalies and integrate with structural models. Now, this is what we mean by beyond the seismic. It's about integrating seismic and other data sets powered by modern analytics to expand the reach of geoscience. We have several case studies. I've put a few companies up here that are at the forefront over the past few years that have been developing advanced technological solutions. We have Equinor, we have Viridian, we have SLB, Schlumberger, we have Halliburton, BP, and ExxonMobil, just to mention a few. In Equinor, they have the Equinor Prevent team, where they have more than 520 machine learning models in production that produce millions of predictions every day. Equinor have also demonstrated that they can identify reservoir fluid content in real time during drilling by analyzing mud gas, which is amazing. Schlumberger have machine learning solutions which are integrated into Petrel subsurface software, which some of us might be familiar with. They provide users with direct access to machine learning capabilities. Also, Schlumberger has the Lumi data and AI platform, which is designed to transform raw data from various sources into trusted insights, enabling better decision-making across subsurface and surface operations. Halliburton, they use their machine learning to provide subsurface insight as well. They improve drilling efficiency, they enhance production operations through their integrated digital platform like the DS365.ai, for those who may have come across that. And all of these solutions leverage historical data to optimize well designs, automate fault interpretation from seismic data, predict beat wear, and analyze reservoir characteristics. And most recently, ExxonMobil, they use their automated machine learning fault forecast approach to increase average production by more than 5% in their back-end gas lift wells, which is also amazing. Being able to get more from reservoirs using machine learning is amazing. That earns you a lot of money and saves you a lot of cost. So what are the barriers we must overcome, right? There are challenges, of course, there always will be. First of all, one I think I would say is up there with the most important things we need to pay attention to is data quality. Like I said earlier, garbage in, garbage out. If your data in itself, your raw ordinary data is wrong, then whatever result you'll be getting will be wrong. Your seismic can be noisy, your well logs can be incomplete, your core data can be missing. Legacy data sets often need significant cleaning. So before you feed your data to train a machine learning model, you'd want to carry out proper data cleaning on that. This is something we need to pay attention to. Also, there's the question of accessibility. That's another challenge where most of our data are locked up in silos, proprietary database, and outdated formats. Like in the UK here, we have the NSTA, that's the North Sea Transition Authority, where their websites, they have the database open source for anybody to go there, download data, study data, use it for research and whatnot. I don't know at the moment if Nigeria has something like that or the equivalent, because a lot of companies like to hold their data close to their chests, even for wells that have already been drilled and in production. They wouldn't want to share that data, which is not great, because if we're going to build solutions, we need access to these data sets. And there's also interpretability, really. So some deep learning models can be black boxes, right? So if a CNN says in a seismic section there's a horizon here, but cannot explain why there's a horizon there, then a geoscientist may not trust it, right? So we need explainable AI. That is critical, because if someone just comes, especially when it's coming from a computer, we're always a bit skeptical. Okay, you're saying this is what it is. How are we sure that that is what it is? So that is why we need to generate more explainable AI. And every day we're getting more results in that field. And then finally, there's the skills gap, right? Geoscientists need at least a basic literacy in coding and machine learning, the basics at least. While data scientists who will be working on geological data, they need to have some level of geological training to avoid producing wrong results, so that when a geologist and a data scientist are communicating, even in their own languages, they know how to communicate with each other. Right, so let's bring it back. Let's bring it closer to home, to Nigeria. Nigeria has one of the world's largest petroleum provinces, with massive data sets from the Niger Delta and other basins. We have growing frontier exploration stories in the Benue Trough, the Anambra Basin, all that. We have mature fields that need better reservoir management. And we also have something that most countries in the world do not have. We have one of the youngest and most dynamic professional populations in Africa, right? We're young, we are intelligent, we're brilliant, we can make solutions. So if young professionals like those on this call can master both geoscience and data science, we can pioneer solutions that are tailored to Nigerian geology, for instance, and not just import models that have been built on, say, the Permian Basin or the North Sea, or most of these Western trained models, because a model will always give you solution based on what it knows. So we can train models on Nigerian geology, Nigerian basins, Nigerian fields, then these models, when applied for future exploration purposes, can give us accurate and useful information. Now, that's the opportunity that we have here for as many of us that are on this call that are involved in one way or the other in the oil and gas industry, the oil and gas landscape in Nigeria. Let's look at this as an opportunity. Let's develop Nigerian-made solutions that will work for Nigerians. And this is not something that is so big. I'm not saying, oh, tomorrow go, I'm not saying go and start a company, or it can be as simple as a little solution. In your day-to-day work, you may have encountered one task or the other that you think, oh, I wish there was a way to make this faster. I wish there was a way to make this simpler. Oh, if only I could do this way. And as they say, necessity breeds invention. So when it becomes necessary, when you think about it, you ponder about it, you have your network, you have the NAPE Young Professionals platform. You can talk with people, both those that are tech savvy, those that are not, get ideas, come together and create something. And with that, I'll move on to the next slide. Just recently, myself and Promise, for those who are familiar, Promise Eke, she's my colleague at Virgin, and we also studied at Fulbright together. We were speaking and we thought, like, okay, how about a lightweight Python library for visualizing seismic data for a start, right? So people who want to view seismic, students, young professionals who may not have access to the big petrol softwares, or even maybe their computers can't even take it, For instance, I remember back in the day, some people say, oh, my computer cannot handle petrol, it will crash or something like that. And then you're looking for just a simple solution to visualize your seismic, interpret seismic, do whatever analysis and whatnot, interpretations you want to do. So we said, okay, let's come up with something that we can use, really. And this is the first time we're actually putting this out there because it's still in very early stages of development, where you can load your segway files, you can visualize seismic slices, you can highlight features, overlay fascies using classification models, and all of this reproducible in a Python environment. So it's not consuming too much memory, and you don't need to pay for a software. It's open source, right? So any of us here in this call, if you have ideas that you want to bring to it, you can contribute easily. I'll put the link to the GitHub repo. It's currently in the slide, so but I can put it in the chat as well. So people can just go there, interact with it. You can start the repo, see what we're doing, reach out to us, let us know, okay, how about we add this? How about we add that? We already have a lineup. And when I say a lineup, there's a lot of things we want to do. Like I said, it's early stages. There's still quite a lot that of improvements that we're going to make, integrating machine learning models, artificial intelligence, and all that into it. And it's going to be amazing. So I'm going to stop sharing at this point and move to the GitHub repo just to show you what it looks like. One sec. Let's see. Please let me know if you can see this, the GitHub repo.
Yes, we can see it.
Great, thank you very much. Right, so this is the SeisViz GitHub repo, and the README file is very extensive. You can read what it's about, what it does. Currently, these are the key features that we have. You can load seismic volumes. You can view inline, X-line, and depth slices with customizable color maps. You can overlay and compare fascies or label data on slices. You can visualize multiple 3D slices in one plot. You can explore amplitude-based structures. You can choose between side-by-side and overlay display modes. And you can even view random inline, X-line depth slices. And the current function modules that we have, functions within this package, you have the load seismic data, plot 2D, show random line, plot 3D, and plot multiple 3D. And like I said, we have a lot of stuff we want to add to it. So these are potential features or modules that we're going to be adding over time. And everybody's welcome to contribute, really. We're going to be doing fault visualizations. We're going to be doing horizon masking, volume metadata, volume animation, synthetic data support, machine learning integration. All of that is going to be in there, and it's going to be amazing. So for those who want to contribute easily, you can pull requests, you can send pull requests and feedbacks. Easy way to start contributing, you can open an issue in the GitHub repo, and then you can fork the repo and contribute, especially if you want to add interactivity, mask, or the ML layers. Just reach out to us. We'll work on it together and make this tool very easy, and so that people who need it can use it, right? Now, for installation purposes, we're going to make it pip installable, but like I said, it's still in the early stages, and we want to add a few more functionalities before we make it pip installable. But for whatever integrated development environment you're using, you can easily just clone the repo and then change directory to SeisViz within that repo, and pip install everything within that and subfolder, and it should work fine for you. So I'm just going to go through the example notebook we currently have in the repo. If you go into the repo, you see the notebook there. I'm just going to go through it and show you just a few examples, really. So this is the notebook we currently have. If you see, I have a folder here called data, where I've gotten open source seismic data. There's a lot of data sets online, really. So if you want to practice how this works, see how you can use it, see how you can improve it, just go online, search for open source seismic data, or you can reach out to us and we can even give you sources where you can get some of these data sets, right? Sorry, is someone asking a question? Or okay,
Please go on.
I'll just continue. Thank you. Right, okay.
Yeah, you can go ahead, please.
Hello, can you hear me?
Yes, I can hear you.
Okay, great. Sorry, I think someone muted me. Okay. So I said you load the dependencies initially, and after you run that, next thing you want to do is create put the path to your data. Now, for those who are familiar with Python syntax, the 2 dots means you're in the current directory, since we're in the same directory and there's a data folder here. So I just put the 2 dots, current directory, go into the data folder. And from there, we're going to load the seismic volume into a variable called volume. So the function for that is SV, which stands for size v's. As you can see here, we're importing size v's as SV. So sv.load seismic data, and you put the path there. So os.path is simply just saying the main path plus the name of the file itself. Now, for this particular example, the segway file has been saved as a numpy file, so .npy, and that's what we're loading. So if you run that, it should run and print the results. So you have the different axes, the X line, the inline, and the depth range. So we can see for X line, we have 400, inline 700, and for depth, we have 254, and that is the shape. So normally in size V's, we have put the default to X line, inline, depth in that order for the shape of the seismic volume. But you can always use the reorder volume. I've commented it out here. But if you want to reorder it and change it to say inline, X line, depth, or X line, inline, depth, or depth, inline, whatever way you want to order it, you can reorder your volume depending on how you want to visualize your seismic. And once you've loaded the data into that variable, the next step really is just to use the functions that we've created. We've done all the back work. So you can just say sv.plot 2D seismic. You put the volume and you put the line number of the seismic line you want to load, and you put the line type. For this example, we've put X line. And if you run that in just a few seconds, it will show you the seismic line. So you have the X line for X line 100, which is what we put initially. So you can also change it. As you see here, we have line type X line. If we change it here to inline, this is what we get. So this is the inline version of that same line number, 100. And in, for instance, because remember we have different inline X line numbers, X line up to 400, and we have our depth up to 254. So you can just select a random line, for instance. So you don't want to show a specific line. You can say, okay, I want to show random line from our seismic volume, but a random X line. And when you run that, it will just randomly select a number. So this is showing line 147 of the X line. You can go ahead and change this to a random inline, and you run that to show you a random inline for this. This is line 208, right? And the map is based on seismic. Now, the next step is if you have Fashi labels. So for this demo, we used an already interpreted seismic data that has labels, Fashi, that has been labeled. So if you see in the data folder, I have labels and the seismic data. So what you want to do is load your labels. So you do the same thing, SV, load seismic data, and you load the labels, and you create a label dictionary, say for different classes, class A, class B, C, and whatever number of classes you have within your label, and you can assign different colors to it. The color variations are limitless. You can always search in Matplotlib to see how many colors you can actually use. So once you run that and you load your labels, you can then go on to plot the same 2D seismic. This time we can use depth as the line type, and we're using our variables, labels, and the label dictionary. So if you run that, takes a few seconds and you see it loads. So now you have the different Fashi labels within the seismic. Now there's a variable that would either display it overlaid on top of the original seismic, or it can be displayed side by side, which we've done here. So the default is overlay, but you can always change it by setting display mode to side by side. So if I run this same one and I set display mode to side by side, it's going to display the actual seismic line and then the Fashi interpretation to the side. So which is great. So you can visualize both side by side. And if you want to see what a function can do, you can easily run help. If you run help, it shows you everything that you might need to set: seismic volume, the line number, the line type, the label, CMAP, and all that, right? And like I said, you can display it either overlay or side-by-side comparison. And that's for 2D. Now for 3D, it's similar. All you have to do is say sv.plot seismic 3D slices. You put the volume, you say in what direction you want it to plot. For this one, we're choosing the depth direction. We can always change that in future examples. And what step do we want it to be in? So we're going to say in step of hundreds. And what do we want to start from for the depths? Let's start from 10. So when you run that, it might take a bit longer than the 2D, but it should display soon. Let's see how long that takes. Okay. It's taking a bit longer than it usually does. Right, I should have just run this beforehand and left it. But yeah, so I'll just keep going, and then when it displays, that'll be fine. So for the 3D, you can plot it same way. You can choose your direction, inline, X-line. Okay, here we go. So for the one we chose, we said start from depth 10, and then for every 100 magnitude of depths after that level, so we have 100, 110, and then 210. And you can see the different levels for this particular depth view of the seismic data. And you can do the same for the inline. It's going to take a long time as well. I'll just run that, and wait, how long does it take? 53 seconds. Okay, so yeah, you can see here that you can view the seismic in 3 dimensions, really. And the next step we're going to add is the ability to be able to rotate this. For now, this is just a Matplotlib output, right? So the next step is to add where you can rotate it, move it up and down, and view it in whatever perspective you would like to. And we'll be adding that functionality soon. And for this one, we've said we want to view the inline, step 100, start at 100. So you can see the inline at every 100. You have several of them that you can plot. And the same with the X line. You can do similar and say step 100 for X line, start at 100, and it will also display all of that like this. So you can easily use this tool to visualize your seismic both in 2D and in 3D. And then you can view multiples. Okay, so this is for the X line. As you can see, similar output. Very good, very clear. And then you can view orthogonal seismic slices, really put in multiple slices in one display. So we can specify that, okay, we want inline of 10, we want the X line 400, and we want the depth of 250. And when you run that, this is what it's going to give you. So you have the 3 dimensions, inline, X line, depth, showing at the same time, right, in 3D. And then you can either use, if you set CMAP to seismic, it gives you the normal seismic color display, or you can set it to gray in CMAP here, and it will give you the gray display option, which some people prefer. And then you can also do multiple slices. So for instance, here we've chosen just inline 10, X line 400, and depth 250. But here we've said, okay, we want 3 inlines. We want 10, 350, and 550. You can also increase the others as well, and it will display like this. So you have the 3 inlines, you have your 1 X line, and you have your 1 depth as stated in the function. So this is just a brief demo I wanted to do for the SizeVis tool. In another month or so, it might look completely different because we're going to add a lot of functions, a lot of advancements to it. So we might even make it an app that you can easily go on a page and just input your seismic data, and you can toggle on and off stuff and make your display instead of using a notebook like in this instance. So I'll just go back to the presentation. Right. So for most of the people in the call, they might be asking, where do I start from? I don't know Python. I don't know any of this stuff. I don't know machine learning. I have no idea how artificial intelligence even works. Well, all I can say is that is totally fine. Everybody will have to start from some point, right? And it's easy, really. All it takes is practice. It's like your ABCs. There's nothing mind-blowing or out of this world about it. It's not rocket science, as they would say. So the first thing you want to do is learn the fundamentals, right? Learn the fundamentals of data science. Start with Python. For the wider use in geoscience, just learn Python. Learn the basics, really. NumPy, pandas, matplotlib, scikit-learn. Learn all that. Try to get comfortable with data handling. Practice working with geological and geophysical data sets. Learn how to clean data, how to integrate data, how to visualize data. The tool I've just demoed now is for visualizing seismic data. You could come up with a tool for well logs, pressure, temperature, whatever kind of geological, geophysical, gravity, magnetic data. You can come up with something for the visualization and analysis of that kind of data. You explore machine learning applications in geoscience. There are a lot out there. So many. If you just type in Google or whatever, use ChatGPT or anything, you can learn so much about that and get open data sets. Now, what I would say the most important thing from this slide really is to leverage online learning resources. There's so much resources out there that are free where you can go on and learn, pick up these skills that you need. Our Market Promises YouTube channel. Promise has a YouTube channel. If you go on YouTube and just search for Promise AK, you see her YouTube channel where she's teaching basic data science, really, so you can learn basic Python for basic data analysis there. And there's so many free courses, Coursera, Udemy, edX, name it, so many. And there's also geoscience focused resources. All the different geoscience associations, they have workshops, they have technical sessions like this one. We could have another technical session where what we could just do is maybe a hands-on start. Everybody comes with their laptop. We do a task. Everybody learns how to code in basic Python. And if you go more and more with that and you practice, before you know it, you're able to start working on projects. And you can just start whatever, small projects, work in teams, work with your colleagues, work with your friends, work with people within the NAPE YP community, and start making headway, creating solutions. And you can share your work on GitHub for free, really, and let people know what you're doing and see the amazing things you're working on. Right. So what's the key message in all that I've been saying, really? I know I've spoken a lot in the past few minutes, but the key message here is that your geoscience foundation is irreplaceable. It's irreplaceable. The rock still matters. All that you've done, all that you've studied, the structure, the stratigraphy, the sedimentology, basin analysis, all of that, it all still matters. But the data skills, they are the new differentiators, right? You know how many geoscientists are out there? There's so many of us. But how many geoscientists can use Python? How many geoscientists know how to build or train a machine learning model? How many of them know how to handle data in an efficient and fast way? Not so much. So that's what's going to make you different. That's what's going to make you stand out. So the leaders of tomorrow are those who can bridge these two worlds together, the world of rocks, the world of data. And you as a young professional, you're perfectly positioned to be that bridge. There are people in the industry, our senior colleagues who are well advanced in age and may find it a bit difficult to adapt and learn these new skills. But we're in a perfect position because we've gained this geoscience knowledge, and we wouldn't want to say, oh, just because we don't know how to code in Python, then we're becoming irrelevant. No, learn the skill, pick up the skill, upskill, and then you will be amazing at what you do. People will come look for you. They will need you. That is what relevance really means. So this is a call to action. Like I said again, start working on improving your technical skills, your data science skills, your data analytics skills, your machine learning skills, artificial intelligence skills. Learn all that you need to. It's easier for you as a geoscientist to learn data skills than it is for a data scientist to learn geology. We all know how geology is. So to learn that, you know how long it will take. But to learn these data skills, they're online, they're everywhere, easy to pick up. And I would appreciate if every one of us can do that. So with that, I've come to the end of the presentation, really. And like Testimony said at the beginning, I'm going to be asking a few questions to see people that we're following. Very few questions, and if you can answer them correctly, you win a prize, which is great. Testimony, how would this work? Is it the first person to answer correctly, or how do you want to do it? Are they raising up their hands or using the chat?
The first person to send the answer to the chat.
Okay, great. Not just the answer, the correct answer.
The correct answer. Yes,
people can send all sorts. But yeah, so I'll go on to the next slide, which will contain the question. The questions are very easy. As you've seen, the presentation has not been extremely technical. I did that on purpose so that everybody can follow. So if you can answer correctly, go ahead. So here comes the first question. So geoscientists mainly bring dash, while data scientists mainly bring dash. Testimony, please let me know when you've answered. I mean, I'll give this is very easy. So I'll say 10 seconds before I move to the next slide, which will contain the answer. Testimony, I can't see the chat. Are we getting answers? Or
yes, answers are coming in.
Oh, great. Amazing. That's good. Shows that people were engaged. Great. I think that's enough time for just these simple questions. So I'm going to move on. So if you're sending your answers, send it within the next 5 seconds. That's if someone has not already gotten it. Right. So this is the answer. Geoscientists mainly bring the context, while data scientists bring the tools. Geoscientists bring context, data scientists bring the tools. Did we get that answer? Did anybody get that testimony?
Nobody got the answer correct.
It doesn't have to be the exact word. Did anybody say anything remotely close to that?
They did. Somebody said knowledge and skill. So that's the closest answer.
Yeah. Okay, yeah, we can give that person. Yes, context,
Or-
geoscience knowledge, while the data scientists bring the tools, the skills. Okay, we'll accept that. We'll accept
All right.
that. I mean,
You
doesn't
can
have to
move
be
on to the next question.
verbatim. Okay, next question coming up now. Mention one way real-time analytics or machine learning can improve drilling or production operations. Just one. I'll give 10 seconds for this. Testimony, do we have answers?
Yes, we have answers in the chat already for that.
Great. Okay, so these are the answers, just example answers I have. So it can help detect stock pipe or kicks. You can use it to optimize drilling parameters. You can use it to forecast production decline, and you can use it to detect anomalies in equipment. Do we have anything close or any other ones they may have mentioned?
Some people were mentioning CNN, identify sweet spots, rates
Okay.
of penetration, real-time sensor analytics, very quick seismic interpretation.
Okay, so the question was in drilling and production. So the answers you said earlier, which ones, who answered? Can you read them in the order of the way they came in so I can know which one to pick? Because there's some that are also related there.
Okay, CNN came first.
No, we're skipping that. Not for real time.
RRN,
No.
identify sweet spots.
Not necessarily. You're not identifying sweet spots while you're drilling and producing already. No.
Then rate of penetration, I think that's the closest.
Yeah. So we can go with rate of penetration really. So you can get that with real data, in real time. You can detect if there's an anomaly, the drill bits, if anything's about to go wrong. So let's give it to the person.
All right.
It's
Please hold
close.
on. Don't go to the next question yet. I
Okay.
want to make an announcement. Some people are
Right.
using just their first name, so it's hard to document.
Ah.
So for the next 1 minute, everyone should put their full name in what is to join this meeting.
Yeah, please.
So we can give the prize to the right person.
That is true.
So in 1 minute we'll continue. Sorry for the delay.
No, that's okay. Just let me know when.
All right.
All right, sorry. Thanks, Testimony, for mentioning that. I think particularly for the first person, Emmanuel, I'd want you to please include your last name, and then Claire.
Yes, those are
include
the
your
two
last
people.
name. So Testimony, please kindly take note of the others as well.
All right.
Yeah.
Okay, can I go on?
I think that's enough time for the change to have been effected. So you can go on to the next question, please.
Right, okay. Next question coming right up. So why is Nigeria especially well positioned to benefit from data-driven geoscience? This one is what I spoke about not too long ago, so it should be easy to answer. What places Nigeria in a great position to exploit this opportunity for data-driven geoscience?
Answers are already in the chat.
Great. So here are the answers. We have vast subsurface data sets from the Niger Delta and frontier basins. We have mature fields. We have a large pool of young professionals to drive innovation. I'm sure definitely someone must have gotten that.
Yes. The first answer that came in, the person said large basins, but I don't think that's the nail on the head.
Yeah, no.
Then the next answer was because we have a lot of data.
Okay. Yes, we do. So I think I'll go with the second one.
All right.
So yeah, we have vast data sets to work with, a lot of data. So that's great. We have an answer for that. Moving on to the next one. According to the presentation, the future leaders in geoscience will be those who dash. This is a sentence answer, and it's simple. So I'll just give some 10, 20 seconds so people can type their answers. Who are the future leaders in geoscience? Who will they be?
Answers are already in the chat.
Great. I'll give 5 more seconds in case the correct answers are not in the chat already. And okay, that's time.
All
So
right.
according to the presentation, it says those who can combine deep geoscience knowledge with data science skills. Surely someone must have gotten that, right?
Yes, somebody
Okay.
has.
What exactly did the person say?
The first person said can bridge the gap, but someone else was more specific and said combination of both knowledge and skills.
Yeah, perfect. So those who can combine geoscience knowledge with the data science skills. And now the last question. The last question is going to be from the demo I did of the seismic visualization tool. So if you were paying attention, this should be really, really easy. And I really hope people were paying attention, because if you don't get this one, it would hurt. So here's the question. What argument would you set to either create an overlay or a side-by-side display of seismic facie labels when using SeisViz? What argument would you set? For those who are not familiar with Python terms, should I say, what settings would you change? That's one way to put it. What setting would you change to either overlay or side by side so that you can see the seismic facie labels when using the SeisViz tool? Do we have any answers?
Yes.
Oh, okay.
Well,
Do you think it's the correct answer? Okay, let's
to learn it.
let's give you a bit more time because this is a bit technical. So some
Yes.
people
Okay.
may need to think a little. And if you are rushing to the GitHub repo to have a look at it, that's cheating. Don't cheat. Just try and think back. And it's very simple. Okay, 5 more seconds. And it's simple. So the argument is called display mode. So you either set display mode to overlay or you set display mode to side by side. Did anybody mention display mode? Testimony.
Yes, somebody, but the person said display side by side, display overlay. Did not specify display mode.
Ah, okay. What do we think? Should we, because that is not the argument though, so that's not exactly the correct answer.
Yes, and nobody else specified with display mode as the argument, even if they said something close to that.
Right. So what are we thinking? Did they fail it, or should we just extend grace and say, okay, since the person mentioned display? Well,
You are
that
you're the jury.
Yeah, let's just give the person. I mean, there's no point holding it, so it's fine. So it's the display mode argument. And yeah, those are the 5 questions I put together, really just to see how engagement was. And it's good to know that people were actually paying attention and learning. So yes, thank you very much. It's been an amazing time talking to every one of you here. Thank you for paying attention. And if you have any questions, please go ahead and ask.
All right, Perkins, thank you very much for the presentation. Please, if you have any question, you can use the chat box or raise your hand if you have any question. All right, there's a question. I'm going to unmute you now, Ibrahim. So you can unmute yourself and speak, Brian.
Hi, good morning. Kindly confirm you can hear me.
Yes, I can hear you.
Okay. All right. Great presentation, Perkins. Really appreciate that one. But my question is not going to be too long, but just I just need to take notes and at least efficiently.
Sorry,
So,
can you project more? Can you project more?
Um,
Your voice is a bit low, so can just
okay. How,
project a bit.
how about now? Is it better? Can you hear me now? Better?
yes, it's better now.
Yeah.
Oh, okay. So I was saying that my question is going to have like a little bit of elements, so you could just like take notes so you can answer as comprehend as efficiently as possible. Yeah. So thank you for the presentation. So for us in industry, yeah, the results of our evaluation and analysis here are tightly they're tightly tied to economic implications, yeah.
Okay.
And given the fact that we work with a lot of subsurface data sets, and we all know that subsurface, or most of us will know that subsurface evaluation is a very iterative process, very, very iterative, and so many scenarios can come and can be inferred. Now, stakeholders, shareholders are going to pump in money and they want to see what ifs, what if this is, what if this is, things like that. So, do you think that models can actually be trained to infer several of these assumptions? Because when the chips are down, no one will be able to say, oh no, a machine did this. It's going to always be pointed at a particular human being and say, oh, you did this, and it happens, they'll say you did this, or this particular set of people did this. So do you particularly think a machine can be trained to actually give several inferences, and the time it would take to actually QC, I mean, I'm talking about the reliability of product this machine gives, do you think it won't take so much time to actually QC this and say, oh, okay, machine, you did a great job? Do you think it will take a short time or long time? Thank you very much.
Okay, thank you very much, Ibrahim, for your very important question. Now, that is essential, really, and I'm glad you brought it up because, as you said, stakeholders, investors want solutions. They want every um, scenario to be covered, right? And the question is, can we trust models to be trained to answer these questions and give the different inferences? My short answer is yes, we can. And to elaborate on that, I would say it's important for you to know that these models are not just going to train themselves or come up with solutions by themselves. I'm glad you mentioned the QC, which is important as well, right? When you train a model as a geoscientist, you're transferring your knowledge base, what you understand, to that model. So it's not like bringing up a model and saying, oh, what is this, or what could happen in this scenario. No, you're first telling the model that okay, sorry, excuse me. You're saying if you're drilling in this particular field and you encounter this, these are the possible scenarios. This is what it might be. And if this certain type of data is this value, then this is what the problem most likely is, right? That is what you're teaching the model. So that's why it's called training a machine learning model. So you as the professional, you that you work in the industry, you understand this data, you have trained it to understand it as well. And the more you train it, the more you tell it that, okay, this is what could happen, this is what it could be, the more it can learn and give you those answers. Now, remember, I said in the beginning that what the stakeholders want to see, what investors want, is quick, fast turnaround. They want to know what's going on. They want to know it really quick. They don't want you to go away and take 1 month, 2 months to analyze or interpret and whatnot. So that's why I also mentioned that your geoscience skill remains very relevant. So it's not that, okay, you run a test using a machine learning model and then it gives you a result and then you just go ahead and present that result. No, that's where the QC that you mentioned comes into play. So you have to do quality control. you have to check, okay, is this answer correct? It's just like when I'm sure every one of us here must have used ChatGPT in one way or the other. When you use ChatGPT, it's like asking, um, well, this thing that ChatGPT has given me, am I just going to copy it and paste it somewhere, or am I going to go through it and see if it makes any sense? So that's why I said, first of all, whatever data you're using to train your machine learning model has to be clean and correct data. Data quality is important because a machine learning model can be wrong. Machine learning models can hallucinate. That is a term for AI models where they start to just manufacture stuff out of nowhere. And it takes a skilled geoscientist to spot those problems. So yes, it would take some time to train the model and then to test it, evaluate it, see if it's working fine, if it's giving the right results. And every day, machine learning models, they're learning more. You can retrain the model, add new data sets to the training set, bring new scenarios in, and it can learn really fast and provide solutions. So it saves you time, and most of the time it saves you money because time is most times equal to money. It saves you time, saves you money, gives you quicker turnaround, and also you can evaluate it. You can always change the settings, you can improve it, make it better and better always. If we remember back when ChatGPT first came into play, it wasn't as amazing as it is today. Now you can generate a whole video in seconds. So there's always improvements. I don't know if I'm answering your question correctly, Ibrahim, if that makes sense to you.
Yes, that's fine. That's fine.
Okay, thank you. I can see there's some questions in the chat. I'll just go through the ones that are here. Testimony, please let me know when we're running out of time. So, Blessing says, thank you for the wonderful presentation. Thank you. Do you see the OSDU being an important platform to close data silos and application dependent issues, thereby enabling AI applications on big data located on a single platform? And how can the Nigerian subsurface community get on with the drive with the international community? As I noticed, there isn't so much knowledge about the OSDU. Well, yes, that's why it's called the Open Subsurface Data Universe. It's one of the initiatives that has been championed so far by my current employers, Viridian. We have the dedicated OSDU team who are doing amazing work. And the good thing about OSDU is that we have different big players in the oil and gas industry using the same standards, the same patterns. So remember what I said, we have accessibility issues with data, where data are in different places, different data silos. But now you have everything together in OSDU. It creates that uniform platform, more sort of like, if I want to put it in data engineering terms, like a data lake house, where you have all the different kinds of data coming together. So yes, the OSDU is going to play a major role. A lot of companies are coming on board. It's growing every day. And how can the Nigerian subsurface community get on with it? It's pretty straightforward, right? I think the way is for those who have access to the data owners actually. So be that the international oil companies, some of which are already a part of the OSDU initiative, and those who are not, to just communicate with the OSD owners, people who are developing the platform, and let them know that they are willing to join this initiative, contribute the data into it. So it's up to you as a young professional to bring this to the knowledge of those in executive positions. Let them know about OSDU. Let them know, oh, I saw this. And like I said earlier, the fear of having data in the cloud is something that is deterring many companies from advancing in digital technology. It's just the same way when a solution comes at first, everybody is skeptical. Fortune favors the brave. Those who jump into it at first, when they start making profit, and getting results from it, that's when other people now want to join the bandwagon. But it's always good to spot the trend just before it gets fully blown. So that's a very good question, Blessing. And yes, OSDU is one example of bringing all of these data types together in an industry-wide um, consolidation of standards where everybody is using the same standards, the same for specific data type, everybody is following the same standards. It's going to help drive innovation and application of AI in the future. I hope that answers your question. Blessing. I'll move on to the next one. With the shift towards digital oil fields, how can geoscientists leverage big data analytics to better forecast reservoir performance under enhanced oil recovery scenarios? Yeah, so that's I think one of the points I touched earlier. Big data analytics to do forecasting is simply training a machine learning model based on what you've experienced in the past. Now, we all know how geoscience works, especially in similar regions. So if you've drilled a well in a particular region before and you've produced from that well, you have all the data, you have everything. You can use that to train a model to be able to predict and say, okay, if for instance, I'm moving from this point to another point, what is going to happen? Or then you can even say, okay, based on these parameters, based on this production data that we have, what can we do to get more oil from this particular reservoir? And then your model can generate scenarios for you, either, okay, use gas lift or use drill an injection well, different means. And then you as the expert will evaluate that and see, okay, you can also just see based on the models, they will always give you some level of accuracy that, okay, based on this, I am 90% sure that this might work. I'm 50% sure that this might work. And then it's left for you to make the final decision on what you want to do. But I want to say that when it comes to forecasting, that's predictive analytics, these machine learning models, they work wonders. For predictions, they are amazing. So you just need to train them right. That's all I keep hitting that on the head. Once you train them right, they will give you the right answers that you need. So I'll move to the last question here on the chat. It says, you also mentioned the need to train on Nigerian data. However, a major constraint in Nigerian data is not publicly available for utilization, like countries like Norway, who make data available certain years after. Yeah, so that's why I said during the presentation, we have to make a start, and the only way to make a start is start talking to the people who have access to this data. Like I said, the data owners, you have to start communicating with them, because that is where the world is leaving us behind. So while we are hiding our data for wells that have already been decommissioned, even we've drilled, we've produced to the point that there's nothing left to produce, you've decommissioned it, release the data, let people learn from it. So as young professionals, especially people in the NAPI community, we have people who are in executive positions across the different oil and gas companies in Nigeria. It might be worth reaching out to them, talk to the NAPI president, see what can we do about this. We need Nigerian data to train Nigerian models. And even if it's as a specific project, really a side project, that people within the community come together and say, okay, what we want to do is gather this data and train a model, and maybe write a proposal to companies asking them for data for wells that have been decommissioned, that the well has gotten to the end of life, the field has gotten to the end of life. Let's get this data so we can build on it. It all starts with word of mouth, really. Every one of us has that responsibility. Let's speak, let's talk, and let's ask for this data. If you don't ask, you won't get it. And like I said, the world is moving at a very fast pace. People are going ahead. Other countries are doing this and they're getting results while we are waiting. And before we jump on it, it might be already late and models would have been way, way, way advanced already. So that's to answer your question, Blessing. And Rukaya says, advice for a geologist interested in high performance computing. Is it compulsory to know machine learning? I don't want to say compulsory because I mean nothing is compulsory. You can do whatever you want, but I would say it is necessary, especially saying you're interested in high performance computing. Learning machine learning is necessary. It's a necessary skill in the geoscience landscape today. And saying high performance computing, or that's just using big terms. This thing is accessible and it's easy. It's easy, it's straightforward. A machine learning model is nothing more than you writing lines of code, providing data sets, training the model, testing the model, evaluating it, saying, okay, what are these results? What did you get wrong? Why did you get this wrong? And then you retrain it, you teach it more. So maybe when I'm trying to talk about it, it might sound a bit daunting or a bit advanced, but it is nothing too complex that you can't learn as a geologist. If you can learn geology, then trust me, you can learn machine learning 100%. I can assure you that. So just give it time, 1 hour a week, 2 hours a week, depending on how quickly you want to learn it. And before you know it, you'll be working with models. Oluwasegun said,
All right.
are we out of time?
Yes, we are, but
sorry, I'm just
I'll allow you to
running
take
through.
this last question.
Okay, I'll just go through this last one. What are the recommended courses and learning platforms for aspiring data geoscientists? Like I said during the presentation, there are so many courses that you can take, but my advice is the first step is learn basic Python. Learn basic Python. Go on Coursera and just look for basic Python course and just learn. Really use YouTube. YouTube is your friend. It's free. There are lots of data science channels that you can use. I remember when I was initially learning, I used a channel from a guy called Alex the Analyst, where you can learn basic Python, you can learn basic SQL. That's amazing to learn from. Promise, like I said, Promise AK, go on YouTube, search for Promise AK. You see her YouTube channel where she's teaching people how to work with data using Python and all that. And I'm sure maybe sometime in the future she might go delve deeper into the geoscience aspect of it, so geoscientists can have something tailored for them. But there's so many courses out there. Oluwasegun, you can reach out to me later. I can provide you with links. Really, there's a lot of stuff out there that you can use to learn, and it is free. Knowledge nowadays is free, so take the most advantage of it. Thank you very much. So yeah, thank you for your questions. Really appreciate it. I'll hand over to testimony. Thank you.
All right, Perkins, thank you very much for that presentation. It was really insightful. I learned new things and I've seen my shortcomings. So there's work to be done. So thank you very much for that. Now I'll be calling on the NAPE YP team lead, Oluwaseun Ogundipe, to give the vote of thanks.
All right. Testimony, can you confirm if you can hear me?
Loud and clear, sir.
All right. Thank you very much. I mean, Perkins, this has been very exciting, engaging, educative. Thank you so much. I want you all on the call to please give a virtual applause, share how you feel virtually for this wonderful session. Yeah, Perkins, Sophie, thank you very much. She's a data geoscientist with Viridian. I mean, I remember this was exactly a week ago. I was speaking with Promise AK, and then on the need to continue our sessions for this month.
Can you hear me?
She said, "Oh yes, hello.
Yes.
Yeah,
Can you hear me?
Yes, I can hear you.
I was going to say apologies before you shut the door and round off for the day. If I could just quickly add my voice to say thanks to Perkins before he takes off. Yeah, so I've been listening in from the very beginning, and I want to say this is a very well chosen topic. And delivery, in fact, the delivery is excellent. So I want to say thanks to you, Perkins, for your time. The slides are quite user-friendly, and it didn't sound like a very super technical thing, yet it is very super technical, right? I want to say thanks for this choice of topic and for the delivery itself, the hands-on session. I mean, come on, we couldn't you couldn't have done better than this, to be honest. I couldn't agree more with anyone that this is a very exciting topic. I particularly like the fact that you're able to showcase how this connects the geoscientist who brings context to things from experience, and the data scientist who brings the tool and the technology, and how they both marry to make us people who lead in the industry of today and of course tomorrow. So I want to just say thanks to you, and continue to do what you do, and say thanks to the YP team for putting this together, and for everyone who attended. Thank you very much, and I also learned listening in all through. Cheers.
Thank you so much, Ifeanyi. Thank you.
Thank you so much, Dr. Ifeanyi. I was going to mention for Dr. Ifeanyi to come in afterwards, but it's good that he's mentioned now. I mean, Dr. Ifeanyi is the University Assistant Program Chair. Thank you so much for your time. I noticed you've been on the session even up until now. Again, maybe before I continue, let me also just recognize one of our very own senior professional that has been very supportive to the YPs, in person of Dr. Ebere Bernard. I see you on the call. Thank you so much for your presence as well. Yes, so I was saying that exactly a week ago, I was speaking with Promise AK, and she already just mentioned Perkins, and I said, oh, that seems to be like a family. That's a familiar name, because as student leaders back then, I mean, we sort of knew ourselves one way or the other. Again, I must thank you, Promise AK, for that connection to make this session happen. Perkins, thank you so much. Like Dr. Obia said, the presentation, the demo, and then again, like I would always share with the members, try to attend our sessions. There are several things that you'll be hearing for the first time. And I must thank Perkins and Promise for also mentioning to the public for the first time their lightweight Python library. If you need more details, like Perkins has shared, you can contact the YP team or you can reach out to them. We'll all be glad to connect with ourselves. I must also thank our moderator for today, Testimony Adamu. Thank you for the well-coordinated and for the good job you have done for this session, right from the start up until the Q&A. Thank you so much. And this session would not have also been possible if not for several people that have been working behind the scene. I must really recognize the YP executives that are also, the executives are also being shared on the screen. And then the technical committee, which is led by Jumome, who also gave the welcome address. And then I know when the session started, there about around 10 o'clock, we had about 10, 15 people, and that number grew to like double of it when we started officially. And we're almost 70. I know it's towards the end, and I know people have to go and do other things. But I want to thank each and every one of you that have stayed up till this time to enjoy one of our sessions as well. Thank you so much for creating time. I mean, this is not just for us as YPs, as YP community. It's really for our individual selves as well. Thank you all so much. Again, I'll just hand over back to Testimony of Abioye. Let's just take some announcements if we have any.
All right, thank you, Mr. Sharon. So I'll call on Abioye to take the announcements, but please, before that, there's a girl, or I don't know if it's a guy. The name is Claire. You are yet to indicate your full name, so please drop it in the chat box while the announcement is going on. Thank you very much. Over to you.
Yeah, good morning. It's still morning. Good morning, everyone.
Thank you so much, Perkins. Thank you so much for everything, for the simplicity, and you know, and thank you also, Promise. Thank you for the recommendation. This is a great one. So I was beginning to say to Mr. Shehu that we should just have this more like a boot camp for the next maybe every weekend for the next 3 months or something, just to help us. But I think we'll get back to that if that will be possible. So yeah,
You are definitely bringing them back.
yeah. Thank you. Yeah, so yeah, so our announcement. So you see, this is just one of our technical meetings. I used to say that we can always bring more people in. When you see things like this that benefit you, you need to share. Sincerely, you need to share. Because I've always noticed that sometimes I can decide to start something personally, and with time I get tired. For people that I called, at the beginning of that thing, that process, that are still in it with me, those people that would cheer me up and cheer me on to actually continue. So look at this now. Excellent presentation, excellent topic. Yeah, the last technical meeting we had an health series, the first of its kind. So health habits on the go. And I hope you guys are still keeping to the health tips that I was giving. So you can always find our recordings on YouTube. Today meeting will also be on YouTube. Latest on the Tuesday, it should be there. So I want you guys to go by it and go by it again. So then yeah, happy activity celebration. The last technical meeting we are anticipating it. But right now it is a story we are living, we are still reliving. You understand? So it was really a great moment, where we had a presentation, panel session, defining the energy landscape for the next 50 years. So now we already lived what's it called, the last 50 years, which has also determined our next 50 years. So now defining it the next 50 years, we had nice what's it called, speech, commentaries, and session on how we navigate the next 50 years ahead. So if you have not, maybe perhaps you were not at the what's it called, the venue that day, or you didn't join online, the recording is still on YouTube. You can always go back and watch. So these are pictures, from the past 50 years. You can see faces you can recognize there. That is our PE president-elect, and that's our welfare center, picture of the far right. Yeah, you can see the team lead, the YP team leader at the top left corner. You can see himself and the team leader at the right top corner. So you can see the young professionals, faces you can see from the picture that it was really a great moment. And here you have the organizing committee. And here pictures, the awards were given to different people shown their hard work in the past years and all that. And monetary values to keep with it too. You can see that on the screen. Yeah, so and after the first session, we had this puzzle fitting in, and at first it was challenging. But you can see here we have the team that really did well. So that's the base center, we set the record straight for others to follow. And then you understand. So here, these are just photo section. Beautifully, you'll find them on our IG page. If you'll be following us, you will start receiving videos, short clips, of the event. And please do like and repost. Encourage people to like and repost so we can have more engagement on our platforms. So here we are. This is our next technical meeting for September. It's just going to be September 6th, which is just around the corner here. What if this is the kind of meeting where you come in and you are rolling your sleeve? Understand? You are rolling your sleeve and you are coming into work. You understand? So here you can see on the screen, participants will bring graph paper, pencil, sharpener, eraser, and ruler. So just make sure you register, you reach out to Che or Ali. His number is right there on the screen. And the time for that day is 11 a.m. to 2 p.m. The location for this is VI. Understand? But the exact location will be indicated to those register, stand the approved people that are registered. So I want us to participate in this. Start seeing it from up to social media as well. So if you're on this call, that means you're among the first set of people who is seeing this. So you can just do well to quickly register now. And note that one of the criteria for selecting you to participate in this is that you must be an active member of YP, up-to-date member of the YP. If you have not done that, so please do that, please. So yeah, then or sometime this 28th, next week, 28 to 30, 12th NAPIN GSP conference, which will be happening at Kwara State University, FASU. So see that if you're a student here, you're a professional, you want to attend, you have to register, please kindly register now. Kindly register now. And if you're a student also, you know, any particular school, you have not submitted, you have not submitted those who are going to be presenting you for this University of Geoscience talent. Please do not send it their name now. We are still waiting. And today, and later today by 5 p.m., we're having a conference town hall meeting. We had one earlier this month, so we're having one again today. So it's against the planning, accommodation, scheme to conduct, and all that towards this mini conference. So please do well to attend, or perhaps you know someone that is supposed to attend. You can share this information with them. It's all on our social media and on WhatsApp. Yeah, so August technical business meeting chapter is also called Tuesday Services of Students. So I want us to plan to attend. It's going to be online too. You can see the Zoom link is on screen. So please do well to register for this as well. So, and finally, pay your dues, pay your dues, pay your dues, and keep saying it and encouraging us to please pay our dues. You understand? So you have to stay connected through your membership to maximize the benefit to prevent suspension. You understand? So just reach out to Mr. Mayowa. His contact is right there on this screen, and this is his email address as well. So please reach out to him. And thank you very much. So always follow us. If you are not following us yet, please do follow us on IG, follow us on Facebook, follow us on Twitter, follow us on everywhere. So please follow us. So thank you very much. And once again, let's watch out for our next technical meeting. My name is Abdul, and I'm the YP Publicity Secretary. Thank you very much. Testimony actually.
All right, thank you, Abdul, for that. And thank you for everyone that joined the session up until this point. It was enlightening, and we hope to see you at the next NAPIYP event. Do enjoy the rest of your weekend, and as we have come to the end of this meeting. Thank you very much.